Hi everyone, Mrs. Musoff again. Here's a second video just to give you a few more examples on piecewise functions if you still have a few questions, or if you just think seeing another example will really help you figure it out. Alright, these are the same notes as before, so we already did example 1 together, even though it doesn't show it here. So, just a couple things I figure it might be helpful to review, and just make sure we remember. Number 1, it says, what does the line f of x equals 7 look like? Well, remember, I said if f of x ever confuses you, just think of it as y. So this really is saying y equals 7. So if I were to draw a little graph here, that's the x-axis, that's the y-axis. Do you remember what y equals 7 would look like? In fact, let me draw this a little better straight. There we go. Ish. Alright, well, y equals 7, hopefully you had this idea, is where you go 1, 2, 3, 4, 5, 6, 7 on the y-axis, and then you draw a line through that point. Alright, so in other words, the line y equals 7 is a horizontal line. So there are going to be times when you're graphing piecewise functions, you might have already seen some, where the piece isn't a line at an angle, like with a slope, it's just a horizontal line. And that's okay. You know it's a horizontal line when the f of x equation is equal to a constant. So if it's ever f of x or y equals a constant. Constant means a number with no variable. Number with no variable. Alright, so if you ever see something like that, for example, we'll see one in the next example, you'll know, okay, that's just going to be a little horizontal line. It's not going to have a slope. Okay, one other thing just to test out, make sure we understand. Number 2, it says, what does this notation mean? Alright, so I know you want to read it left to right because that's how we read most things. But actually here we really want to read it starting with the variable. And so if you remember doing ones like this, we kind of broke it apart and we turned it into an and inequality. And the way we did that is we started with this middle piece, the x, the variable, and we read it from the x to the left, and then we read it from the x to the right. So from x to the left it says x, and since the bigger part is facing x, it's x is greater than -2. And then since it's all written together, this is an and inequality, so x is greater than -2, and the other one is easy, it's x is less than or equal to 3. That one reads normally. Okay, another way to think of this is this basically is just saying x falls in between -2 and +3. Falls in between -2 and 3. And just if you see that little line with one of the symbols, that means it's allowed to equal that number. So can equal 3. Alright, can't equal -2, but it can equal 3. And the reason that's helpful to know is because every so often we'll have a graph that has that as one of the conditions, something like this whole thing. Okay, and that means on your graph between -2, let's say right there, and 3 right there, you'll have a little graph, right, a little line. And it won't have arrows going past it because it's only for the numbers in between those 2 points. And so instead what you'll do is those 2 numbers will become your boundary points, and you'll just have a little short line connecting those 2 dots. Alright, so let's take a look at an example so you can kind of see what it looks like. Alright, we'll look at one of each of these. So we'll look at both of these so that we can kind of get a sense for what's going on. Alright, so example 2, f of x equals, once again we have 2 pieces, y equals 3x, and y equals x plus 5. And then we see our boundaries. Alright, that's right here. So the first boundary, x has to be less than -2. The second boundary is one of those trickier ones. It says x is greater than or equal to -2, and x is less than 4. Or in other words, x falls in between -2 and 4, but it can equal -2. Alright, so this graph will look a little different because of the way that second condition is written. But we'll worry about that when we get there. Let's start with the first condition. Alright, first condition mentions -2, so I'm going to draw that first little line at -2. So I know that that's going to kind of separate these. And I'm going to use -2 as my first x value. Alright, because we always use that boundary point. For my second x value, I can pick any number as long as it is less than -2. So I'll go with -3. Keep it nice and simple. Alright, and then I'm going to plug these in. The equation I'm using is y equals 3x, that first one. So this will be y equals 3 times -2, which is -6. And then this one will be y equals 3 times -3, which is -9. So here are my 2 points. Alright. Now remember, it's just the boundary point that you need to check open or close. So in this case, my boundary point is at -2. So I'm going to look at my symbol. And since there's no equal to sign, right, like right here, no equal line, that's how I know it's going to be an open circle. So my first boundary point here, I'm just going to label it with open so I remember. But if it's not a boundary point, it's automatically closed because it's just a normal point. So the second one will be closed. So I have -2, -6, that's open. And then -3, -9, which is closed. And since this is going all the way to the left, right, because less than -2, I can draw that arrow. And there's my graph. A little crooked, but good enough. Okay, it's the second one that'll be a little different because the second one, instead of just having one boundary point, it actually has 2 because there are 2 boundaries there, right? So this graph is going to start at -2, but then it's only going to go until 4. So I'm going to draw another line at 4 so I know that's where it stops. All right, it's not going to keep going, it's going to stop at 4. And actually, that makes it kind of nice for this excuse me, for this table, because I don't even have to choose my x values. If there are 2 boundary points, then I'm going to use both of those points as my x values. So it's kind of like a little less you have to worry about because they just gave you the 2 x values. Alright, this equation is y equals x plus 5, so I'll take these 2 x values and I'll plug them in. -2 plus 5, that's 3. And then 4 plus 5 is 9. So I have 2 points, -2, 3, and 4, 9. Now since both of these are boundary points, I need to check both of them for open or closed. And the way you can always tell is by looking at the sign that's right next to the number. So like the one that's right next to the -2 is equal to, that means it could equal -2. So the -2 point is going to be closed. But the 4, that's strictly less than, so it can't equal 4. That means it's going to be open. Oops, sorry. So I'll have my closed point at -2, 3, shaded in, and an open point at 4, 9. Open it up. And so this will be different because I'm just going to connect these dots, but there's not going to be an arrow because it only exists between those 2 points. And then I'm done. So this graph just happens to not have a piece on the right side. All right, every so often you'll get one like that. All right, let's try one more example, just again, in case it'll be helpful to see. So example 3. Notice on this one doesn't have a table, so you're going to just draw it yourself. No big deal. I'm actually going to draw it exactly like we had before, just to keep it consistent. So I'm going to put x here. I'm going to put my first equation, which is just y equals 8. And then I'm going to put the y value there. Okay, so that'll be my first table, and then I'll do the same thing for my second one. Ugh, sorry about that. Keep doing that. Sorry, not as straight, my fault. X, my second equation, y equals -2x plus 14, and then y. Alright, so once again I've got these conditions, and it's another one of those double conditions. Alright, so this one says x has to be between -10 and 4, but it can equal -10. And this one's x has to be between 4 and 8, but it can equal 4. Alright, so for this first one I'm going to draw my lines at -10. And at +4, this is a big range here. And so this first graph is going to happen in between these 2 lines that I drew. And again, the nice thing about having the 2 conditions is I know my x's. They're -10 and 4. I'm going to use both of them. Okay. Now, this right here maybe looks a little familiar. This is that constant function we were talking about. There's no x in it. It's just 8. That's awesome, because that means I don't even have to plug these in. I know the y value already. No matter what the x is, my y value will be 8. So I have my 2 points. All right, I have negative 10 comma 8 and 4 comma 8. Now, since they are both boundary points, I do have to check open or closed, and again, I'll go off of the sign that's right next to those numbers. So negative 10 will be a closed point, but positive 4 will remain open. So negative 10 comma 8, that will be my closed point, and then 4 comma 8 will be my open point. And remember what we said, the constant function should be a horizontal line. So this is making sense because it is a horizontal line. Alright, and then we'll do our second graph. Second one, again, it's saying x needs to be greater than or equal to 4 and less than 8. So between 4 and 8. So I'm going to draw my lines at 4 and 8. I already have one at 4. So now I'll just do one at 8. And that means those two numbers are my x values, so I'll write them down. Now this one's not constant, so I do actually have to plug it in. So it'll be negative 2 times 4 plus 14. So negative 8 plus 14, that's 6. And then down here we'll do negative 2 times 8 plus 14. That's negative 16 plus 14, so negative 2. So again, my 2 points, 4 comma 6 and 8 comma negative 2. Once again, both boundary points because they're both numbers up here. So I do need to check open or closed. The 4 has that equal to line, so that'll be closed. But the 8 doesn't, so that one will be open. Alright, so 4 comma 6 is a closed point. 8 negative 2 is my open point. Again, no arrows because it's just in between those 2 points. And there's my graph. Alright, so hopefully those extra examples have kind of helped fill in any gaps that you might have been having with these piecewise ones. That doesn't mean you won't still have questions. I expect it. Piecewise functions can be kind of challenging. So don't be afraid to ask in class or stop by the resource room if you don't get a chance to ask in class. And hopefully these piecewise functions you can figure out by the end of Tuesday. That's all. Thanks for watching. Thanks for listening. See you in class.